Okay, today we're going to look at section 12.3, solving radical equations. We'll start off nice and simple. And a radical equation is an equation which contains a radical and obviously with an equal sign. That makes the equation. So there's a simple one. The square root of x minus 7 equals 0. Now, we're going to use exactly the same principles that we've always used to solve these problems, which is getting the order of operations right, so remembering PEMDAS, and doing the inverse operations in the reverse order. So what is happening to the x, it's being square rooted. Now that is an exponent, and then there is subtraction. That's what's happening to the variable, and obviously it's happening in this order. Now the inverse operation, the inverse of subtraction is addition, and the inverse to the exponent is another form of exponent. Okay, so what we're going to do is we'll do that. So root x minus 7 equals 0. We're going to add 7 to both sides. And then we are going to square both sides. The reason we square both sides is in order to get rid of the square root of x. So if you have the square root of x and you square it, and that means you multiply it by itself, square root of x times the square root of x equals the square root of x squared, which equals x. Okay, so squaring a square root will essentially remove the radical, but we have to do the same to both sides. So square root of x squared is x, 7 squared is 49, and we have our solution. Okay. Now, that was a very simple one with the operation outside the square root, that's root x minus 7. Let's do a different type of problem this time. Our operator is within the radical, square root of x minus 5. Now, in this case, we have a square root happening, we have a subtraction, but we also have parentheses. The radical itself is a form of parenthesis. And we need to do this first. The minus 5 that is happening to the x is locked in. It cannot be released until we have, sorry, I don't mean to equal 0. Let me do a different number there. The negative 5 is locked into the square root symbol, into the radical. And we need to release it. And we release it by squaring both sides. And what we get on the left-hand side, the square root of x minus 5 all squared is x minus 5. The effect of squaring the square root is to remove that radical symbol. And 7 squared is 49. Now we can do our inverse operations as usual. So x equals 54. Okay. Now these can get more and more complicated. Let's look at another one. This time there are 2 additional things happening. There's a multiplying by 3 and an add 4. What we need to do here is all the components which are outside the radical must be removed first. So we dividing by 3 in order to remove that. So we end up with square root of x plus 4 equals 5. We now need to remove the radical symbol. We do that by squaring. So x plus 4 equals 25. X equals 21. Okay, let's do one more complex example. Okay, again, operations both inside and outside the radical symbol. We clean up the outside first. square both sides. We can then solve normally. Okay. Right, so it's time for you to do something. So page 707, and we'll do questions 18 through 32. I'll just include them here. Okay, quite a lot to be getting on with. As before, once you've completed the problems and you've checked your solutions on the rear wall and you're comfortable that you understand this particular element, then move on. So pause the recording now and get on with these problems. Okay, welcome back. We're now going to look at what are known as extraneous solutions. Now, these are problems where the answer in some way does not make sense. So let's have a look at this. We'll have a very simple one. Quite an innocuous looking equation. Square root of x plus 13 equals 0. So we subtract 13 from both sides. And we get square root of x equals negative 13. Now, you may well be tempted to continue and say, okay, I know how to do this. I square that, and I square this, and I get x equals 169. But were you to do that, you will have ignored a glaring fallacy, what we call an extraneous solution, a problem. And let's go back and see where that problem is. And the problem is there. The fact is the problem is that a square root cannot be negative. So at this point, when we find the square root of x is a negative number, we say, okay, there is no solution. Okay. Right, so the next set of exercises have a number of examples of these problems with no solution. It's on the next page. And the questions are 40 through 54. I shall include them here. There they are. Now, not all of these problems will have no solution. So don't just go through all of these saying no solution to everything. Some of them certainly will have a solution. The first one, for example, is quite obviously has a solution. So work through these. When you get to this, if you discover that there is a problem, that there's an extraneous solution, write down no solution. Okay, I'd like you to finish off by working through the word problems on page 708. So the problems I'd like you to do are questions 37 and 38. And then 55 to 56. I'm going to go through both of these problems in a few seconds. Pause the recording now, attempt these problems, and then see if you agree with my solutions. Okay, we're going to go through question 37, 38 now. Okay, there's the problem. It's related to nozzle diameters and pressures. Okay, so they give us an expression or an equation which relates the flow rate of the antifreeze, the nozzle diameter, and the nozzle pressure. Okay. You want a flow rate of 250 gallons per minute. All right. Okay, so what we need to do now is essentially substitute the values we've been given into this particular problem. Okay, so flow rate, we're looking for 250 gallons a minute. So the various things there are is 250. Find the nozzle pressure P for nozzles whose diameter is 1.25. 1.25 goes in there, and we don't know P. So let's put those numbers into this expression. Okay, so 250 equals 30 times 1.25 squared times root P. So let's simplify that. So we divide both sides by 30 times 1.25 squared, gives us root P. And then we square both sides to find out what P is. I'm going to start with the P. So that gives us P equals 250 over 30 times 1.25 squared. And if you put that into your calculator, you'll get P is about 28.4 pounds per square inch, PSI. All right, nice and easy. Second problem, exactly the same question, but this time the diameter is 1.75, and we can put that directly into our problem here. So in this case, we'll do it in a different colour. P would be 250 over 30 times 1.75 squared. So that's the second pressure, and that would be 7.4 psi. Okay, great. Right, last problem. Okay, this question looks very slightly different from the one in your textbook. The only difference is the image. Here it's a woman hammer thrower, and I think in your book it's a man, but everything else is the same. The question is identical. So once again, we read through the problem and we identify that we are being given an equation. There we go. S equals 1.2a. A is the centripetal acceleration, and S is the speed that the hammer is thrown. Okay. So again, it's a straightforward substitution problem. So we look at question 55. S equals 1.2, the square root of 1.2a. S, they're telling us, is 18 meters per second. So 18 equals root 1.2a. We need to square both sides. And then we need to divide by 1.2. A is 18 squared over 1.2. And if we work that out, we'll see that that is 270 meters per second squared. All right. Question 56 is identical, but this time it's 24 meters per second. Meters per second is the speed, so we'll try same problem with that. So the second answer, instead of being 18 squared, it's 24 squared over 1.2. And that gives us 480 meters per second squared. Okay. All right, that's it for the chapter or for the section. Your homework will be 12.3b, and that should be being distributed to you now.